All right, let's get into it. Excited today. Very excited. Up to question 14 of these HSC questions. We better get onto it. Righto. Have a look at question 14. We'll do this in two parts because I haven't got enough room, obviously. Question 14 of the dreaded area under the curve worksheet. Thanks for helping out. The two functions, fx 4x cubed minus 4x squared plus 3x, that's sitting on top, same as we had a look at before. Top function sitting above another function below. Bottom function is 2x. All right, first part, similar to a lot of the questions we've looked at, is we need to find the x coordinate for our lower limit, our upper limit. Giving away a few marks to build up to the area under the curve. So if our job is to have a look at the point of intersection, and really concentrating on the x coordinates. Sometimes I think one of the questions forever is asked us to have a look at the coordinates for x and y, but this time it's just asking for x. All right, so we've said this is where they intersect. So we've set the function 4x cubed minus 4x squared plus 3x. That equals 2x. That's the point of intersection. Solving that equation. Minus 2x, bring that across. 4x cubed minus 4x squared plus x equals 0. Bit of a nasty job to factorise all this. I've got an x, an x, an x, so x come out the front. Factorising all this bit here. Now my job is to factorise that. And that goes back to prelim stuff. That's why we worked on it so hard. It's one of those ones with a 4 out the front here. It's a 1 at the end, so you probably could have guessed, maybe. I'm not a big fan of the guessing stuff, really. Bit, not so much. Anyway, we are going to proper factorise. 4 ones, that's how we did this. So 4 ones are 4. So I'm looking for a product of plus 4. And I'm looking for a sum of minus 4. So 4 ones, let's remember when the coefficient of the x squared is not a 1. It's 4 ones are 4. And the sum is minus 4. So I'm trying to find the magic combination for that. Ouch. Minus 2 times minus 2. I'm paying attention, of course, that how can you have a plus, products being plus, but still at the same time end up with negatives? Well, there's only one way you can do it, is 2 minuses. So minus 2 times minus 2 is plus 4, and minus 2, well, that should be a minus 2 there. Adding on another minus 2, and we'll fix that one up. So adding on another minus 2 there makes minus 4. So that's the combination we need. So putting that together, factorising this, 4, there it is there. I've rewritten this, broken it up into, it's called grouping in pairs, if you can't recall. So minus 2x minus 2x, minus 2x minus 2, that's still the same as that one there. But now I've broken it up into 2 sections. Remember to wriggle a little line down there. 2x is our common factor at the front here. So there's the front bit. 2x times 2x is 4x. 2x times 1, there's that bit there. So I really want this one to occur back here. 2x plus 1. So we'll make it 2x minus 1. Chuck the minus out here. So that's 2x minus 1. 2x minus 1. So the bits left over. It's another 2x minus 1. Right, so putting all that together, x times 2x minus 1 times 2x minus 1. What are we doing all this? Oh, this goes back to the point of intersection. That's that. Rewritten as factorised. So I can make all this equals 0. So if that was a 0, check. If one of these was a 0, so 2x minus 1 equals 0. Solving, solving, solving. X equals a half. So clearly our 2 points are x equals 0 and that side equals a half. Or I'll pause it there and I'll just reset. All right, cleaned her up. Continuing on, part 2, area of the shaded region. If you're not getting this by now, top function minus the bottom function. Now it has to be the whole thing. We looked at one in the previous video. We said it has to be the whole thing minus the bottom function. If you don't put it in brackets, you can really screw it up by missing a minus or something like that. Anyway, we should be right today. Let's keep going and have a look. 4x cubed minus 4x squared plus 3x. Take off 2x. Done all that there. 4x cubed minus 4x squared plus x. 3x plus x. Integrating all that. 4x cubed. 4x 4 on the 4. But be careful to integrate all properly. Chucking the numbers, relatively simple. The 0 here, probably going to be 0, 0, 0, 0. That's that bit there. But the half, now again, same as before, being very careful. The most trickiest part is this putting this into a calculator. We've got brackets, we've got times, we've got fractions, we've got powers. It all comes with the burden of stuffing it up. And again, being honest, I've stuffed up so many times. Just be so careful. So it's a half of the 4, 1 on 48 square units. All right, we'll go on to question 15 in a sec. All right, let's have a look at question 15. It's back. What have they done this time? Check on the HSC exam paper, certainly the one that I supplied. Once again, that on the page, they wrote this function down here, attached to there. So they wrote it down there. And they wrote this information for this function, 2k x squared minus 1. They actually wrote it up there. I'm looking off to the side there. It's written there. All right, so be warned, when we're doing that area under the curve, our top function minus the bottom function, we want to make sure that we really clearly identify our top function is this one here. And if you notice, it looks around from your page, it writes that information right there. And this function here looks around and they write the value of this function right there. So on first glance, our top function, bottom function, that's not strictly right. Remember, we want to identify our top function as this one, our bottom function clearly as this one. All right, so again, be warned, just make sure you clearly identify top function and bottom function before you start diving on in. A pretty good question, a bit different this time. Again, you don't know where you're going with this, but you know, have a crack, just see what happens. Top function, this bit, minus the bottom function, and again, please make sure that you've written it clearly in brackets. This whole section minus this one. If you remove the brackets, you're going to, we'll notice down here in a minute, minus. If you don't have this written as separate bits, you're going to end up having this as a minus, and you're going to screw it up because it ends up being a plus. All right, so be very careful of that. Now, notice also in the solution, because they're parabolas, symmetry, it's not a great diagram. Symmetry says this side's exactly the same as that one. So in the solution, what they've said is, if I just find from 0 to 1, that'll give me the same. If I double that area, I'm going to have both sides. They were probably thinking a little bit ahead to realise that when we do our upper limit, lower limit, having a value of 0 in there is really easy because it often just becomes 0, and integrating it would seem that way. Over here, we've solved it and we've had to use both values, the 1 and the minus 1. And that's probably something to keep in mind, especially when you're dealing with parabolas because of the symmetry. Anyway, moving ahead. Top function minus the bottom function. Expanding all that out, not diving in too early to watch for the minus. Minus becomes a plus. All right, now, putting all that together, k's and the 2k's, kx squareds. Putting all that together, we end up with 3k minus 3kx squared. Relatively simple integration. I think people might freak out a bit when they see this 3k business and go, oh, I don't know what to do, Well, it's really treated just as if it was a constant term. If we had to integrate what 5 was, well, that would have been 5x. Most of them happy with that. Now, if it was 3k, just treat it the same deal. If that was an x there, differentiating it would have left us 3k. All right, so just putting an x on. So just practice those, make sure. Same deal, another constant term here. So dealing with the x squared, x cubed on 3. Thankfully, the 3's cancelled out. Leaving us 3kx minus kx cubed. Solving that, put the 1 in. 1 cubed. Putting the minus 1 in, you can see why now. The 0 would have been easy. This would have been zeros and double the 2k. Straight away turns it to 4k. We did it the hard way, using 1 and minus 1. There's 2k there. This is 3k plus, I think that's supposed to be a k. A little bit of it out there. Minus, ends up being minus 2k, minus becomes plus. 4k equals 8. And then hence, k equals 2. All right, thanks guys. See you next time.